Hello friends, we have completed 4.5 exercise. That is the basic algebra for the matrices. Now, the important topics is that the matrix multiplication. Number of the students are facing this problem. Only there is silly mistake of the numbers, and if you do very properly, you can get the matrix multiplication. Now in this video, we will see up to the example number 1 to 7, and in the next video we will see the remaining problems. Now let us start the exercise 4.6. Now we'll start the exercise 4.6. I am now writing the exercise 4.6. Evaluate the given matrix is of the order 3 by 1 and the second matrix is the order 1 by 3. Now see this, A is of the order 3 by 1, 3 rows and 1 column, and B is of the order 1 by 3. Now in this case, if we want the product AB, that is A is 3 by 1 and B is 1 by 3. B is 1 by 3. Now always when we want to product, that is 1 1, which is in blue ink, must be equal. That is the column of the first matrix and row of the second matrix must be equal. And what is the order of their product? The order of their product is 3 by 3, which is the rows of the first matrix and the column of the second matrix, which is the 3 by 3, will be the order of the resulting matrix. Now you see this first. When we make the product, that is the AB, the column of the first matrix equals to rows of the second matrix. Now here order of A is 3 by 1, both of them are equal. Again see this picture, which is 3 by 3. These two factors must be equal. The column of the first matrix equals to the rows of the second matrix. Then the order of the resultant matrix is the rows of the first matrix into by column of the second matrix. Now we see the product. Now see this, how the product is. It's a very important. One matrix is the column matrix and another matrix is the row matrix. Now 3 is multiplied with by 2, then 4, then 3, and that will be the first row of the new matrix. 3 into 2 is 6, 3 into minus 4 is minus 12, and 3 into 3 is 9. It is written in the next. Now see this. My next number 2 is coming multiplied with the 2, minus 4 and 3. 2 into 2, 4. 2 into minus 4 is 8 and 2 into 3 is 6. Therefore 8, 4, minus 8 and 6. And 1 will multiply again the elements 2, minus 4, which is their multiplication is 2, minus 4 and 3. Now this is the matrix multiplication. In this way we want to carry out their multiplication, and the order of the resultant matrix is 3 by 3. That is first row, first column, first row, second column, first row, third column, and in this way we are getting the total first row. This is the answer. Next is the order of the first matrix is 1 by 3 and the order of the second matrix is 3 by 1. That is the 3 row and 1 column. Again, the 3 and 3, these two elements are same. That is the column of the first matrix is equals to the rows of the second matrix. And next the order of the resultant matrix is 1 by 1, which is the 1. Therefore, AB is equals to 2 minus 1 3 and 4 3 1. Therefore, the product is first row, first column. That will be the single one element and order is 1 by 1. 4 into 2, 8 minus 1. 4 into 2 minus 1 into 3 next. And 3 last number multiplied with the last number, which is 1. 3 into 1, that is, this is the single element. 8 minus 3 and plus 3. Minus 3 and plus 3 will be 0 and that is equals to 8 and which order is 1 by 1. Therefore, AB is equals to 8, which is the single element. You will learn how to make their product. Now, number of examples are there. A is a matrix whose order is 2 by 2. B is a matrix whose order is 2 by 2. 2 rows and 2 columns. And show that AB is not equals to BA. Means what? Matrix multiplication is not commutative. Now, if A is equals to this A11, A12, A21, A22. And B is equals to B11, B12, B21, B22. Now AB is equals to, now we'll make the first row, first column. First row of the first matrix will multiply with the first column of the second matrix. That is A11 will multiply with B11. A12 is B21. Now see this. A11 into B11. A12 into B21. And this will be the first element of the new matrix. Next is again A11, B12 plus A12 into B22. This will be the second element. And now second row, again first column. Second row is A21 into B11 plus A22 into B21. Now see this very properly. Next is A21 into B12 plus A22 into B22. Now see this very important. Had given corresponding multiplication of the numbers. First row, first column, that will be the first element. First row, second column, that will be the second element. Second row, first column, that will be the third element of that matrix. Now see this. That is 1 minus 3, 4, 2. 4, 1. 3 minus 2. Now the multiplication. First is 1 into 4. Plus minus 3 into 3. This will be the first row, first column. First row, second column, 1 into 1 plus minus 3 into minus 2. Next is second row, first column, 4 into 4 plus 2 into 3. And second row, second column. And in this way, we will get, that is a 4 minus 9, 1 plus 6, 16 plus 6, 4 minus 4, and that is equals to minus 5, 7, 22 and 0. This is the AB. AB is equals to minus 5, 7, 22 and 0. Next is, this is it, number 1, BA. that is equals to 4, 1, 3 minus 2. And next is 1 minus 3, 4, 2. Now the product is first row, first column, 4 into 1, 1 into 4 plus 1 into 4. Next 4 into minus 3 plus 1 into 2. Next second row, first column, that is a 3 into 1 plus minus 2 into 4. Second row, second column, 3 into minus 3 plus 2 into minus 2. And therefore 4 plus 4 is 8, minus 12 plus 2, 3 minus 8, minus 9 minus 4, that is 8 minus 10, minus 5, minus 13, and this is the second. And therefore from 1 and 2, and therefore from 1 and 2, AB is not equals to BA, means matrix multiplication is not commutative. If A is equals to minus 1, 1, 1, 2, 3, 0, 1, minus 3, 1, and B is equals to order of A is 3 by 3, and order of, now see this B is also 3 by 3. State whether AB is equals to BA. Now here justify your answer. Now see this, the matrix multiplication, both of them have the same order, and the order of AB will be 3 by 3 and the order of BA will be also 3 by 3. Now first AB minus 1, 1, 1, 2, 3, 0, 1 minus 3, 1 into, next is 2, 1, 4, 3, 0, 2, 1, 2, 1. Now we'll make their product. First row, first column, minus 1 into 2, 1 into 3, 1 into 1. First row, first column, first row of the first matrix will multiply first column of the second matrix. See this, minus 1 into 2 plus 1 into 3 and 1 into 1. Next is first row, second column, minus 1 into 1, 1 into 0, 1 into 2. And last is minus 1 into 4, 1 into 2, 1 into 1. Next is second row, first column, 2 into 2 plus 3 into 3 plus 0 into 1. Next is 2 into 1 plus 3 into 0 plus 0 into 2. And last is 2 into 4 plus 3 into 2 and 0 into 2. 1 into 2 minus 3 into 1 and 1 into 4 minus 3 into 1, that is a third row, first column. Now third row, second column, 1 into 1 minus 3 into 0 and 1 into 2. I will change it now. Next is 1 into 4, that is third row, third column, 1 into 4 minus 3 into 2 plus 1 into 1. I will make the change there. Now see this, minus 2 plus 3, 1, minus 1. Now their normal multiplication is there. The letters are small. If you see on the big screen, that is minus 1, 0, plus 2, minus 4 plus 2, 1, 4 plus 9, 0, 2 plus 0, plus 0, and last is 8, 6 and 0, and next is a 2 minus 9 plus 1, 1 plus 1, that is 4 minus 6 plus 1. Therefore, you will get overall 2, 1 minus 1, 13 to 14, and next is minus 6, 2, just time change that is the number 2 element, minus 6, 3, and last is minus 1. That is a 2, 1, minus 1, 13 to 14, and in this is number 1. Now next is find out BA. Now here is a 2, 1, 4, 3, 0, 2, 1, 2, 1 is multiplied by A, that is minus 1, 1, 1, 2, 3, 0, 1 minus 3, 1. Now first row will multiply the first column. First row means what? 2, 1, 4. Multiplied with the first column means what? Second matrix first column, that is minus 1, 2, 1. Now see this. Next is first row, second column. First row of the first matrix will multiply. Now last is first row of the first matrix will multiply third column of the second matrix. Now next row, second row of the first matrix will multiply first column of the second matrix. Again, second row of the first matrix will multiply by the second column of the second matrix. See this corresponding multiplication. And last is second row of the first matrix will multiply third column of the second matrix. See this multiplication. And third row of the first matrix will multiply first column of the second matrix. Then next element is third row of the first matrix will multiply second column of the second matrix, and last is third row into third column, third row of the first matrix into third column of the second matrix. And now this is simple multiplication. You can perform it. It's very simple. Each and every steps I had written its corresponding element. You can check it by stopping the video, and if you think that sir it is your speed is high, you can make on the computer your speed low. Also on mobile you can make your speed also low, also the tablet. Now see this multiplication. Now this chapter is for the 12th standard, that's why you learn very well for the matrix multiplication. Also this is important for the CET and the JEE purpose. That is now the first column, first row is a 4 minus 7 6, after 1 minus 3 5, and third row is 4 4 and 2. This is number 2. We'll see, that is from 1 and 2. AB is not equals to BA, and our conclusion is that the matrix multiplication is not commutative. Now the question number 4. Show that AB is equals to BA, where A is equals to minus 2 3 1, minus 1 2 minus 1, minus 6 9 minus 4, and B is equals to 1 3 minus 1, 2 2 minus 1, 3 0 minus 1. Therefore, now see this. Now the order of the matrix A is 3 by 3, order of the matrix B is a 3 by 3, and the resultant matrix, whatever that the BA is equals to also 3 by 3. Now see this. First is BA, that is the multiplication is minus 2, first row, first column, first row, second column, and first row, third column of the second matrix. Multiplication is. Now, second row of the first matrix will multiply first column of the second matrix. Next is second row, second column. And last is second row, third column. And next is third row, first column. Third row, second column. And third row, third column. Now see this. Third row, third column. Minus 6 into minus 1, 9 into minus 1, minus 4 into minus 1, and in this way. Minus 2 plus 6 minus 3 minus 6 plus 6 0 and 2 plus 2 plus 2. Therefore, you will get minus 1 plus 4, minus 1 plus 4 minus 3, minus 3 plus 4, 0. Next is 1 minus 2 plus 1, minus 6 plus 18, minus 12, minus 18 plus 18, 0. 6 minus 9 plus 4, and then you will get 1 0 0 0 1 0 and 0 1 0. That is equals to identity matrix. Now next is, in the first I must write there AB, but instead of AB I had written there BA. Now see this here. Now this is BA and it is written in this manner. Now see this. Now this is a multiplication. BA, first row, first column, first row, second column multiplication is carried out, and first row, third column corresponding elements multiplication. Now see this, how I had multiplied it. Second row of the first matrix multiplying with the first column of the second matrix. Second row of the first column now multiplying the second column of the second matrix corresponding elements, and the next is second row of the first matrix will multiply corresponding elements of the third column of the second matrix. Now third row of the first matrix, their elements will multiply correspondingly to the first column of the second matrix, and third row, second column, third row, third column, and in this way you can get their multiplication. We'll get their values. That is -2, -3 plus 6, 3 plus 6 minus 9, -1 minus 3 plus 4, -4 minus 2 plus 6, and all the elements. Now we will get the identity matrix there. That is a 1 0 0 0 1 0 0 0 1. Therefore, from 1 and 2, AB is equals to BA, and matrix multiplication is commutative. Now, the second, A is equals to cos theta, sin theta, minus sin theta, cos theta, and B is equals to cos theta minus sin theta, and the cos theta. Now there is a small correction is there for the matrix, that is a first A matrix and the second row is minus sign. I had made their correction. Therefore, the order of the both matrices are same. It is a 2 by 2. First row will multiply by to the first column of the second matrix. First row, second column of the first. Second row, first column. Second row, second column. Multiplication is carried out. Sin square theta plus cos square theta is 1, and the two terms get cancelled, and we'll get the identity matrix. AB is equals to 1 0 0 1. Now BA, cos theta minus sin theta, cos theta, bracket complete, cos theta, sin theta, minus sin theta, cos theta. Now their multiplication is cos square theta plus sin square theta, sin theta into cos theta, minus sin theta into cos theta, sin theta into cos theta, minus sin theta into cos theta, and last is sin square theta plus cos square theta, and we get 1 0 0 1, and AB is saying this is second one. AB from 1 and 2, AB is equals to BA, and matrix multiplication is commutative here. Now verify A in bracket BC is equals to AB into C in each of the following cases. Number 1, A is equals to 1 0 1 2 3 0 0 4 5, and B is equals to 2 minus 2 minus 1 1 0 3, and the matrix C is 3 2 minus 1 2 0 minus 2. Now A into BC, here is equals to AB into C. Now LHS is equals to, first we will find out the product BC, then it will multiply with A. Now find out the BC. The B matrix whose order is 3 by 2 and the order of C matrix is 2 by 3. Therefore, now the resultant matrix, that is the product BC, has the order 3 by 3. First row, first column. First row, second column. First row, third column. Now my first means for first matrix. Second means for second. Now second row, first column. Second row, second column. Second row, third column. Third row, first column. Third row, second column. And third row, third column. Now in this way we can perform the multiplication. You can stop the video and see this, how the multiplication has performed there. Carefully you can get the total idea. I had done number of the times multiplication until and up till you will get to how to make their product corresponding elements. That is a 2, 4, 2, minus 1, minus 2, minus 1, 6, 0, minus 6. And next is A into BC, that is equals to, it is now multiplied with matrix A, and the order of these two matrices is same here, that is a 3 by 3, and their product also has the order 3 by 3. Now see this, first row, first column. All the rows of the first matrix will multiply with the column of the second matrix, and that's why the order of the matrix is always first row. Order of the matrix is always written first row and then column. First row, first column. First row, second column. First row, third column. Now next is second row, first column. Second row, second column. Now multiplication is carried out there. Now second row, third column is there. See these corresponding elements, their multiplication. Third row, first column, now multiplication is third row, second column. Third row and third column. Now this is the multiplication. We can perform it. Normal multiplication is there. That is 8, 4, minus 4, 1, 2, 1, and next is 26, minus 8, minus 34. Now the next is A in bracket BC. Now RHS is equals to AB into C. Now first multiplication will take place, that is AB, that is A into B, and we will perform the multiplication of AB, and the order of A is 3 by 3, B is also 3 by 3, no problem. We can perform their multiplication. This is the AB, that is equals to again first row, first column. Next is first row, order of B is 3 by 2. Now see this. Now the order of the resultant matrix is, that is a 3 rows and 2 columns are there. Now see this multiplication, corresponding elements. This is the second row, and now third row. That is, there are the 3 rows and 2 columns. Therefore, order of the resultant multiplicative matrix is 3 by 2. Now next, this is the AB. Now AB will multiply with C. See this, 2, 1, 1 minus 1, minus 4, 19 with the C. 3, 2 minus 1, 2, 0 minus 2. Now we'll see this again, 3 by 2 and 2 by 3. Therefore, the product ABC has the order 3 by 3. First row, first column, first row, second column, first row, third column. Now second row, first column, second row, second column, second row, third column. That is last is second row, third column, and next is third row, first column, third row, second column, third row, third column. This is the multiplication you can perform. It's very easy. You can stop this video and see this, how the multiplication is carried out there, and then perform it. Now the multiplication is, that is 6 plus 2, 4 plus 0, minus 2 minus 2. Next is, and third row is minus 12 plus 38, minus 8 plus 0, 4 minus 38. Number of the elements are there, that is 8, 4, minus 4, 1 to 1, 26 minus 8 and minus 34. This is the second one. From 1 and 2, LHS is equals to RHS, and hence that is A in bracket BC is equals to AB into C. Now next, second one, A is equals to 2, 4, 3, minus 1, 3, 2, and B is equals to 2, minus 2, 3, 3, minus 1, 1, and C is equals to the matrix 3, 1, 1, 3. The order of first matrix that is BC is equals to 2 minus 2, 3, 3, minus 1, 1, and C is 3, 1, 1, 3. Now see this here, 2 minus 3, minus 2, 1, 2, 1, minus 2 into 3, 3 into 3 plus 3 into 1, 3 into 1, and 3 into 3. minus 1, 3, and next is 1 into 1, minus 1 into 1, 1 into 3, and this is the BC. And there, that is a multiplication. 6 minus 2, 2 minus 6, 3 plus 9 plus 3, 3 plus 9, minus 3 plus 1, and minus 1 plus 3. That is a 4 minus 4, 12, 12, minus 2, and 2. Now it is multiplied with A. Then we will get A into BC, that is equals to 2, 4, 3, minus 1, 3, 2. Next is 4 minus 4, 12, 12, minus 2, 2, and the multiplication. Therefore, next multiplication, first row, second column, second row, first column, second row, second column, now carry out this multiplication. 8, 48 minus 6, next is minus 8 plus 48 plus 6, and minus 4 plus 36 minus 4, 4, 36 and 4. Now normal simplification is there. 50, 46, 28, 44. Therefore, their multiplication will be now next is 2, 4, 3, minus 1, 3, 2, 2 minus 2, 3, 3, minus 1, 1. Now see this, their multiplication. First row, second row, first column, second row, second column, their multiplication is carried out in this way. Now we will add it. See this, 2 rows and 2 columns are there. Order of the matrix is 2 by 2. That is 13, 11, 5, 13. The order is 2 by 2. Therefore, AB into C, that is a 13, 11, 5, 13. 3, 1, 1, 3. 13 into 3 plus 11 into 1. 13 into 1 plus 11 into 3. And in this way, second row, first column, second row, second column. This is the multiplication. (39 plus 11), 13 plus 33, 15 plus 13, and 5 plus 39, and that's equals to the required matrix. Or you see this. This is important. That is 50 and 46. 28, 44. This is the AB into C. This is number 2. And therefore, from 1 and 2, A in bracket BC is equals to AB into C. Now next is question number 7. Verify that A in bracket B plus C is equals to AB plus BC in each of the following matrix. Now the main motto of this exercise is that to perform the multiplication. Now here what we'll do, that is first we'll add AB plus C, then we multiply to them, that is with A. Next is AB and BC. Now see this, LHS, A in bracket B plus C, that is A is 4 minus 2, 2, 3, and addition of these two, that is a B plus C. That is a minus 1, 1, 3, minus 2, plus. Again, see this. And that is equals to their addition of these two matrix. That is a 4 minus 2, 2, 3, and 3, 2, 5 minus 1 minus 3. Now the multiplication is there. Two by two matrix, first, second row, first column, and last is second row, second column. Now their multiplication. That is a 2, 14 and 21 minus 5. Now see this. That is a LHS, that is a A in bracket B plus C. Now the RHS, that is AB plus AC now. Now see this, that is a 4 minus 2, 2, 3, minus 1, 1, 3 minus 2, plus 4 minus 2, 2, 3. Now the multiplication is 4, 1, 2 minus 1. Therefore 4 into minus 1, and next is minus first row, first column. Now see these are multiplication, first row, first column, first row, second column. Next is second row, first column, second row, second column, plus first row, first column, first row, second column, second row, first column, second row, second column. Therefore, it is a minus 4, minus 6, 4 plus 4, minus 2, 9, 2 minus 6 plus 16 minus 4, 4 plus 2, 8 plus 6, 2 minus 3, and hence we have the result minus 10, 8, 7 and minus 4. That is 12, 6, 14 minus 1. and their addition is, this is the addition, and that's why their addition is 214, 21 minus 5, and in this way AB plus BC is equals to 214, 21 minus 5, and that's why from 1 and 2, A in bracket B plus C is equals to AB plus BC, and it is approved. AB plus AC. Now we'll see in the next video. Till then, goodbye. In this way, we have completed question number 1 to 7. I hope that you understood all the problems whatever I had explained here. And again, if you have doubt, write in the comment section of this video. And suppose that if you are new for this channel and if you like this, then subscribe it and share it with your needy friends. Now we'll see in the next video. Till then, goodbye.